Before watching the video, don't forget to subscribe to our channel by clicking the subscribe button below and clicking the bell icon to be notified whenever we publish a new video.
Home-built hydraulic ram pumps. The useful designs show you how to pump water for free. Step 1. Getting the parts ready. The galvanized plumbing parts you buy will be coated with cutting oil and sometimes even have grease of rust inhibitor sprayed on top of that. This combination will then cause dust and dirt to stick to them during shipping and handling. All of this oil and dirt buildup will need to be completely removed in order for the paint and resin to properly adhere or stick to the fittings of your finished pump. I have used a combination cleaning process of spraying the parts with oven cleaner first, letting them sit for 20 minutes and then rinsing and scrubbing them in a 5-gallon bucket of hot soapy water. Don't forget to use safety precautions when using products such as oven cleaner. Rubber gloves and eye protection are highly recommended. Next, I use a liquid dishwashing detergent in hot water that handles grease well. Pay special attention to the threads. Use an old toothbrush to get into the thread grooves. Then rinse all your parts thoroughly in clean water to get the soap off. At this point I use an air compressor to blow off any remaining water. Compressed air works very well for getting water out of the threaded ends. You could also use paper towels and a blow dryer to get them as dry as possible fairly quickly. Even setting the parts out in the sunshine for an hour or two would really help. Leaving water on them will cause them to quickly develop a fine layer of rust. This is not really a problem, just wipe them down before final assembly. Step 2. Making the holder assembly. This is where you will be sealing a 1-inch street L inside of a 2-inch street L using fiberglass resin to bond and permanently seal the parts together. This is the critical piece that separates the high-pressure output side of the pump from the low-pressure input side of the pump. Care needs to be taken to do the best job you can to eliminate the possibility of air leaks in the system. You will need to fashion a tool to hold the 1-inch street L securely with a gasket to keep the resin in place around the 1-inch street L until it sets up. This is fairly easy to do with a piece of 1-inch galvanized pipe, a section of PVC lavatory drain pipe and a modified lavatory drain gasket. The drain gasket fits nicely around the end of the 1-inch pipe and is just a little too large to fit inside the 2-inch street L, so you will need to trim it down some. An easy way to do this is to find an old screwdriver where the handle fits tightly into the 1-inch pipe, chuck the screwdriver into your drill motor as shown and use 100 grit sandpaper to remove the excess material by running the motor and sanding off a little gasket material at a time. Take your time and check the fit often so you don't remove too much material from the gasket too fast. Of course, check the pipe for burrs and sharp edges prior to sanding. Use caution and go slow. It has been my experience that you can get this resized very accurately in less than 5 minutes with lots of test fittings as part of the process. Do your best here, as this is one of the most critical pieces in the production of this mount. It will keep the resin from leaking out before it completely sets up. This tool can also be made with 1-inch PVC glue-on slip fitting and a few inches of 1-inch PVC pipe. Step 3. Building the air chamber, check valve mount. Now that you have cleaned all the oil and grease off of the galvanized parts and dried them, you're ready to start the construction of the check valve mount. Gather the parts and supplies together to begin the assembly process. You will need the 1-inch and 2-inch street Ls, the modified lavatory drain gasket with the holder and a piece of PVC drain pipe. Use this to cover the 1-inch threads during the resin pour. It's handy but not necessary if you are careful. This is not a critical piece if you pour the resin slowly. Get together the rest of your supplies: fiberglass resin and hardener, a plastic Ziploc bag, scissors, acid swabbing brush and Vaseline to coat and protect the threads from the fiberglass. I like to use a piece of PVC drain pipe slipped over the 1-inch holder to back up the lavatory gasket. Use latex available at the auto parts store to keep the fiberglass resin off of your hands. They also aid in cleanup, you just throw them out. Secure the 2-inch street L in a level position during the construction of the mount. I prefer to use a vise for this. Be careful not to have the vise holding it so tightly that it compresses the fitting out of round. Another method is to use a couple of other 2 inches fittings to secure the 2 inches street element during the fiberglass pour if you don't have a vise handy. Remember that the one-way check valve will be installed on the 1-inch threads and will need to have a level, even seal. Take your time to get this as accurate as possible. Using one of your brushes, carefully apply Vaseline to the male threads of the 1-inch street L and the female threads of the 2 inches street L. Also put a thin layer of Vaseline on the threads of the 1-inch holder tool you made and on the face of the gasket so it will be easy to get apart after it has set up. Take your time to get the 1-inch street L carefully positioned inside the 2 inches street L so that the check valve will be as vertical as possible and have clearance on all sides. This is where it is important to use the imported fittings. They have a thinner wall than the US-made fittings and are more forgiving on the clearances. It is possible to make modifications to the 1-inch street L by carefully grinding the flare down on the female side to get a better fit. This should not be necessary with the fittings that come from Asia. Once you have the 2 inches street L in a supported level position, carefully insert the 1-inch street L inside of it and attach the holder tool with the gasket. Shine a bright light into the top of the fittings and look from the holder side to see if there are any gaps around the gasket. If there aren't any gaps, great, you're ready to go to the next step. If you see light coming through, then the resin will also come through and you don't want that to happen. I have found with certain brands of fittings that you may have to either use more than one gasket or move the gasket further back on the threads to where the fit and seal is better. This is not a problem. Just use a thin coat of Vaseline on the parts so that you will be able to easily get them apart later on. Fiberglass when set up is a very tough and unforgiving material, great for the strength of the finished fitting, not so great when you're having trouble getting the holder tool out. During this fitting stage, once again make sure that you are able to get the 1-inch threads into the center of the 2 inches female side of the street L. Sometimes with parts made in the USA the clearances are too tight to make this happen without grinding down some of the flare on the female side of the 1-inch street elbow. Keep working on it until you have the necessary clearance for the 1-inch check valve. Now that you have the parts secured and level, you're ready to work with the fiberglass resin. Pour about 1 inch of the fiberglass resin into a Ziploc baggie. About 2 ounces or more, add hardener. Follow the directions on the resin can for adding the hardener. Normally it's about 15 drops of hardener to 1 ounce of resin. Don't add too much hardener as this will cause the resin to hot set faster than you want it to. I have found that when the weather is cooler, about 35 drops into a baggie with an inch or so of resin seems to work just fine. This is also where a blow dryer can come in handy to warm up the fittings and also help get the fiberglass mixture warmed up. Mix the hardener thoroughly into the resin for 7-10 minutes or until the resin is the consistency of honey, still able to flow easily but not runny. If the resin gets thicker faster than you want it to, you can either add more resin or a small amount of acetone to thin it back down to a workable consistency. When you're ready to pour, simply snip off one of the corners of the Ziploc bag and carefully fill the cavity around the 1-inch street L with the resin up to the level of the threads. At this point, test the position of the 1-inch street L to make sure that you will have the clearance available for the 1-inch check valve. One way to ensure this is to temporarily thread in a 2 inches PVC fitting and then the 1-inch check valve just to make certain of the fit. Put these in finger tight and be careful not to get resin on them. Use a screwdriver to help orient the one-way valve toward the center. Use caution when doing this to keep the parts level and true. Don't pry hard enough that you cause the gasket to skew and the resin to start leaking out. At this point, use your blow dryer to warm up the fittings and help the fiberglass hardening process get moving. Once again, don't get carried away with the heat here, we don't want this to set up too quickly. Give it 24 hours to set up and then check your work. Remove the holder tool and gasket from the fittings. It is common for the resin to shrink up some during the curing process, even to the point of starting to pull away from the sides of the fittings if it's set hot. If you didn't use too much hardener or external heat source, this should not be a problem. Check the resin to make sure that there are no large cracks in it before continuing on. Check the casting and threads on the fittings. Carefully clean up any globs of resin caused by spills off the insides of the fitting and threads with a small chisel or knife. Since you coated them with Vaseline, any small spills should come off easily. Finish the cleanup by using a small amount of acetone on a cotton shop towel to wipe out the fittings. At this point it's a good idea to once again clean the mount unit with hot soapy water using your old toothbrush to get into the threads. Make sure you completely remove any Vaseline residue and dry the part thoroughly. Now is a good time to double check the fit of the 1-inch check valve to make sure that it has the necessary clearance to fit into the neck of the air chamber. If it doesn't fit, you will need to start the process over again. Good news is that the parts are fairly inexpensive and you now have experience. Once you have verified the fit is good, it's time to again level the part and the vise or another 2 inches fitting. Take a small amount of fiberglass resin thinned down with acetone and carefully smooth or paint it around the top and sides of the original fill. Making sure you get any small fissures or cracks between the hardened fiberglass and the sides of the 2 inches street L and also around the neck of the 1-inch street elbow. Keep the part level and warm and give it another 24 hours to completely set up. Congratulations, you are now finished with the most complicated piece of the entire pump's construction. Be sure you do your cleanup in the slop sink, not the kitchen sink, to keep your significant other happy. Chapter 4, Initial Assembly of the Hydraulic Ram Pump Main Body. Lay out your parts before you get started just to make sure you aren't missing any critical pieces. You will also need to have the following tools and supplies to do the job. 1. 2 pipe wrenches capable of handling 2 inches parts. 2. Adjustable wrenches for installing any gauges or valves. 3. Teflon tape. 1/2 inch wide roll for the smaller parts and 3/4 of an inch or 1 inch wide roll for the larger parts. 4. Liquid thread sealant to ease the installation of the tank, check valve. It can also be sealed with Teflon tape and a wood dowel if you're careful and patient. 5. PVC primer and PVC cement. 6. Paper towels or cotton shop towels for cleanup. 7. If you don't have a vise handy, you can also use tools with wooden handles to put into the plumbing parts for leverage and support while tightening the fittings. With that said, this is a great reason to go out and get that bench vise. It will prove to be very useful, especially during this phase of the construction project. Before you actually begin assembling the pump body, check it over for burrs and sharp edges that can either cut you during assembly or cause leaks later on. Of course, the parts should be clean, dry and oil-free from your earlier work scrubbing them down with detergent. Start off by getting the male threads of your parts wrapped with several layers of Teflon tape. Use the wider tape for the bigger parts and thinner tape for the smaller parts. Start off by wrapping the tape on in a clockwise fashion while looking straight at the threads as shown. This will help in the installation by having the tape wrapped in the reverse direction from when you thread the parts together. It will help ensure more tape gets pushed into the gaps if the tail doesn't get bunched up. Not critical, but it is helpful. Go ahead and get all the fittings taped up and put aside while you're on a roll. Start with one of the 2 inches tees, secure it in the vise so you have easy access to the right-hand side and top opening. Thread the tank, check mount into the end of the 2 inches tee and torque it in pretty tight. The goal is to have the tank, check mount as level as possible with the top opening of the 2 inches tee as shown. This is a good time to have a piece of pipe for leverage or have your weightlifter nephew come over to help grunt out that last quarter turn. This is where having that vise is going to start paying real dividends. Now get the output tee ready by installing the bushing. Prepare to paint the inside of the pump body. Seal the holes with PVC plugs or use plastic wrap and rubber bands on the main body of the pump with the check tank mount. Paint the inside by pouring some of the rust-inhibiting paint directly into the large opening of the tee. Tip the body back and forth and side to side to make sure you get good coverage all over the inside. Drain the paint back into the can and set on cardboard or newspaper with the 2 inches opening down to allow the excess paint to drain out. Use one of the inexpensive foam brushes to paint the inside of the other 2 inches tee with the bushing. Set aside and give them time to dry. After a couple of hours, come back and take the caps or covering off to get better air circulation and faster drying times. You could even speed drying a little more by using a blow dryer to warm the parts up. Remove the PVC caps or plugs for good airflow and set aside to let dry. Chapter 5, Initial Assembly of the Hydraulic Ram Pump. Air Pressure Tank Assembly. You will now need to have the length of 4 inches Schedule 40 PVC pipe, rounded pipe cap, 4 inches PVC pipe coupler and bushing, and the wheelbarrow inner tube handy. This is a good time to read the instructions for the PVC primer and cement that you will be using. Because of the size of these fittings and the constant water hammer effect, use PVC primer as added insurance. Determine the length of the pressure chamber. With the 12 inches inner tube, you will need to make sure you have the necessary room for it inside the pipe. Cut a section at least 10 inches long, this one is right at 14 inches. Since we are using the inner tube to maintain air volume, the length is not critical for this particular design of pump. When you cut the pipe, try to get the ends as square as possible. This will help ensure that more surface area is in contact with the fittings when glued together, making the assembly as strong as possible. Once you have cut the section for the pressure tank, there will be burrs and sharp edges. Since you will be installing a rubber inner tube inside this chamber under constant fluctuating pressure, be sure to file off the larger burrs and then sand the shoulders to smooth and round them off. This will help ensure that the inner tube lasts a long time. Wipe the filings and sanding residue from the inside of the pipe with shop towels. Get the PVC glue ready to go by mixing it up well. I like to start by installing the end cap. First step is to apply a layer of primer on the outside last 2 inches of the pipe and also inside the cap itself. Then move quickly to the PVC cement and repeat the process. Cover the last 2 inches of the pipe over the primer and then inside the pipe cap. Push the cap onto the pipe while rotating the cap a quarter turn or so. Be sure that the cap is completely seated onto the pipe. It will have a tendency to want to back off some for a few seconds. Be aware of this and apply constant pressure to keep it well seated until the glue starts to set. This only takes a few seconds but is important to have as much surface area as possible holding the parts together. Remember that this will be operating under constant high pressure. The rounded Schedule 40 PVC cap versus the cheaper squared-off versions will handle this pressure better. Next, move on to the 4 inches coupler. Prepare the ends of the pipe and the fitting in the same manner with the primer first and then the cement. Do your best to work quickly so the PVC glue is still pliable and easy to work with during the assembly process. Remember to give it a good quarter turn while pressing together and hold in place securely for several seconds so the parts don't try to back off each other while they are setting up. Now is a good time to insert the 12 inches wheelbarrow inner tube into the pressure chamber. With the filler tube towards the opening, of course. You will want to be able to gain access to it periodically to keep it aired up. This looks like it would be difficult, but by using an air chuck that is a longer one designed for large highway truck steel tires, you can get to it to add air later with very little trouble. Go ahead and add some air to it right now. There really is no set pressure. You will want it to be firm and yet still pliable. The water will compress it further once the pump is in operation, so it's not really a critical issue. Use the primer and PVC cement to install the 4 inches slip to 2 inches female pipe bushing. Allow the PVC to set up for the required amount of time, check the PVC cement instructions, and then install the 2 inches by 21/2 of an inch pipe coupler. Be careful when installing the steel pipe into PVC, pay close attention to threading the nipple and straight. It's very easy to cross threads and cause yourself headaches. Also be cautious about how much pressure you put on the 4 inches tank while holding it steady in the vise. The PVC cement is completely unforgiving. You don't want to have to start over on the tank at this point. Chapter 6, Waste or Impetus Valve Hydraulic Ram Pump. Conversion of a one-way valve into a waste or impetus valve. For the HRP11 pump you will need to have 2 each of the 1-inch one-way check valves. For the 2 inches pump you will need to make a 2 inches waste impetus valve conversion much in the same manner. Or choose another size for your impetus valve greater than 1 inch but less than 2 inches. The only difference between the HRP11 and HRP12 is the size of the waste impetus valve. Choosing the correct size depends on the amount of water flow you have available at the source and the amount you need to use or pump on any given day. Good rule of thumb would be 5-10 gallons per minute. Stay with the 1 inch. If you have more than 10 GPM, then you can make your choice based on the amount of water you need delivered and how much you want to spend on the valve. I will cover the modification of a 2 inches foot valve into a waste impetus valve as another option for the HRP22 pump later on. First step in the conversion process is to remove the retaining nut, cup washer and spring as shown previously. You will need the waste impetus valve conversion parts you picked up off of your earlier list. The size of the coupling nut, standard nut and bolt is determined by which size valve you will be converting for your pump. Stainless steel is recommended, but the lighter alloy parts will work well too, especially in low water conditions where you need the lightest parts possible. The next step is to use a drill bit to enlarge the hole on the faucet washer to fit over the original valve stem firmly. I recommend you do this by hand and not with a drill motor. It will only take a few minutes and you will be able to have more control over how much material you remove. Insert the stem back through the body of valve and push the washer onto the end. Thread the coupling nut onto the stem and tighten securely. You may use a thread locking compound if you wish, but I have never had any trouble with a coupling nut coming loose. Next you will add the bolt and nut for additional weight to help keep the valve open longer and opening sooner during the cycle. The amount of weight you use will be based on the volume of water you have available and experimenting to find a happy medium during operation. This is a great place to start. That's all there is to it. You have now converted the one-way valve to a waste or impetus valve. Set aside and move on to the next section. Chapter 7, the concrete base hydraulic ram pump. Forming a solid foundation. Ram pumps thump with each cycle when operating and need to be mounted securely to ensure that they don't move around or tip over during operation. For a permanent installation, be prepared to use pipe clamps set in a concrete pad or build a form to encase the lower part of the ram body in concrete to keep it well secured. Keep in mind that when you have your pump set up and operating, you will want to make sure that the body is level and the air chamber is vertical. Take the time to get this as true as you can. The pump's valves will last much longer. This is easy enough to do by using plumbing clamps, straps, or building a small form and encasing the pump body in concrete. For this construction project, I'll be making a form out of 5/8 of an inch chipboard and encasing the pump body in concrete. Start by measuring the length of the pump's body. In this case the HRP22 was just over 12 inches long. To add weight and stability, I'm going to make the base 8 inches wide. Measuring from what will be the bottom to the tops of the fittings is right at 4.5 inches. Using these two measurements we'll cut out the pieces to build a form from the chipboard. For the HRP11 and HRP12 pump body, I used 5/8 of an inch chipboard, drywall screws, and 1/4 bag of high-strength concrete with a trowel and 5-gallon bucket to mix it up in. The base equals 1 piece at 6.5 x 8.5. The ends equals 2 pieces at 4.5 inches by 6.5 inches. The sides equals 2 pieces at 4.5 inches by 9 3/4 inches, added 1 1/4 inch for the chipboard thickness. Use drywall screws to assemble the form. Be sure to pre-drill the holes or the chipboard will split. Don't forget to put a couple of nuts or washers between the bottom of the form and the pump body so you will be able to get the body completely encased in the concrete. Use your torpedo level before and after the pour to make sure everything is as square and straight as possible. Use the PVC caps to close and protect the top of the pump and stuff rags or paper towels into the larger 2 inches opening to keep the concrete out. After pouring, set the pumps in forms aside and give them at least 24 hours to set up before carefully removing the forms. After a minimum of 24 hours, remove the forms, the rags and paper towels from the pump body and use a wire brush to get any concrete residue out of the 2 inches threads. Be extremely careful with the base at this point as it will crack easily. Concrete does not reach its full strength for almost a month. You can help the process along by misting the concrete with water a couple of times a day. The base will turn more of a lighter ash color as it dries out and sets up. Be sure to give it at least 2 or 3 days hardening time before you continue the construction process. Or use extreme caution not to break the base. Chapter 8, Final Assembly Hydraulic Ram Pump. Bringing it all together. At this point there is only one additional modification to check off before the final assembly can take place. Don't worry, this is a really easy one. The 1-inch one-way check valve needs to seat nicely on the check tank mount unit you made earlier. Place the valve into your vise bottom side up, arrow pointing down, and draw file the bottom of the valve so that it is square and flat. Draw filing is simply the process of laying the flat side of the file onto the work, holding the end of the file as well as the handle and pulling it towards you. In this manner you are able to keep an even constant pressure across the valve and get a nice flat area. Be sure to work from several angles, turning 90 degrees one time, 45 degrees another, etc. until you have it worked down as shown. This only takes a few minutes as the brass is pretty soft stuff. Be sure to clean the debris out of the file often to get a nice flat surface area. Installing the one-way check valve onto the tank check mount is the next step. Using a liquid thread sealant makes the job a lot easier. You can also do this with Teflon tape and the round wooden handle of a paintbrush or piece of dowel. It takes some time to get it wrapped in there but can be done. Keep in mind that this is the seal between the lower pressure drive side and the higher pressure output side of the pump. Do your best to make sure this is a secure and leak-proof seal. Thread the valve on by hand as far as you can, then using another tool with a wooden handle inserted in the pump input for leverage tighten the valve with a pipe wrench. Work carefully so you do not crack or damage the fiberglass resin. Next, thread on the converted waste impetus valve and tighten down securely. It helps, and you should have already installed the bushing into the T-fitting. Thread this on with a 2 inches close nibble and tighten securely. Once again use plenty of Teflon tape and pay close attention to how much torque is applied, being careful not to damage the fiberglass resin inside the tank check mount unit. The bushing should end up pointing in the general direction of where you will be pumping water. Another trick you can use for leverage is to gently secure the handle you're using for leverage into your vise while the other end is inside the pump body. Install the pressure tank on top of the 2 inches T and tighten it down securely. Make sure that you have aired up the inner tube first. I like to add a pressure gauge, union and shut-off valves to my systems. This is not required but helps a lot with getting the system started as well as determining how it's functioning. The added benefit of having a ball valve on the delivery line is that you can disconnect the pump without draining the water out of the delivery line. If there is any chance that the line will freeze, it's best to go ahead and drain it. This aids in servicing the pump and getting it back up and running quickly. I will go over this in more detail later on. Final step is installing the drive pipe connection. In this case I am using a 2 inches PVC male with a 2 inches slip to 1 inch female pipe thread. Next is a 1 inch union and then the 1 inch ball valve with a threaded in connector for the drive pipe, which is 100 of 1 inch 160 pounds per square inch black poly pipe for one of the tests. The output pipe connector is for a couple of 100 feet of 1/2 inch black poly sprinkler pipe running up the hill to my delivery site. As for the HRP11 or HRP12 homemade hydraulic ram pumps, congratulations, you're done. With this part anyway. Next for you is the field work to install and test. Chapter 9, Gauges and Valves Hydraulic Ram Pumps. Finishing touches. I don't call out the gauges and valves during the construction process, but they are an integral part to getting the pump up and running as well as making the pumps easier to service. Gauges are important to assist in troubleshooting and to let you know how well the pump is performing. Let's get started in going over the basic parts you should consider adding to your pump installation. Even with some of the larger 2 inches pumps that I have made, I have yet to install a personal delivery system with anything but 1/2 inch poly pipe. I do like to take the output side from 3/4 of an inch down to 1/2 inch on most pumps. If you have a need for a higher delivery volume and have the drive water available, go for it. When setting this up, be sure to include a valve to shut off the water supply to the pressure gauge when you're not actually using it. The constant pulse of water pressure will make it short-lived if you don't protect it. The union is great for being able to disconnect the pump and bring it back to the shop to service or what have you. There is a no-ring on these that will come out really easily, don't lose it. The ball valve after that will allow you to get the pump started quickly and will also keep the delivery pipe full of water when servicing. It takes a while to get it full again if you don't have one. Well worth the investment. Valves and unions on the input side are a necessary part if you are going to collect the pump in the winter and put it away, or to just make it easier to disconnect and store. On the left is the connection assembly to go from 2 inches Schedule 40 PVC drive pipe into the pump. The 2 inches ball valve and union add about $20 to the cost of the pump. On the right is the slip clamp connection for the 1-inch black poly drive pipe with a 1-inch ball valve and 1-inch union into the bushing going back to 2 inches pipe for the HRP11 inlet. It can also be helpful to install a pressure gauge on the inlet side, but is not really necessary. With all of these accessories you will be adding an additional $50 or so depending on what you can find or discount. In my opinion, the benefit is there to install them. Chapter 10, Test Setup. The test system install and results. First thing is to determine the flow of the stream using a 5-gallon bucket. This is a small fast-moving stream that has seasonal highs and lows. This was in the late fall during a pretty wet time in Washington state with a flow of 60 gallons per minute. We chose to capture the water upstream where there is a culvert under the road. As you can see from the debris, the stream moves lots of silt, sand, rocks and other junk downstream all the time, especially in the winter months during high runoff times. On the plus side, this stream comes right out of a rock face about 2 miles upstream, so it's really the product of a high output spring. Many more are in the area adding to the flow all the time. The collection tank used for this setup is a 55-gallon food-grade barrel. With 2 1-inch pipes feeding into the barrel, we were able to fill it completely to overflowing in just over 3 minutes. There is enough fall in less than 50 feet of supply pipe to overfill the barrel. Results for the hydraulic ram pumps. Stream runs at slightly greater than 60 gallons per minute during this time of year. Fall measured from the ram pump side to the barrel equals 10 feet. Drive pipe is 160 psi black poly 100. Lift measured from the ram pump side to the top of ravine equals 45 plus feet. The HRP11 filled a gallon jug in 1 minute 45 seconds. Be sure to get all of the air out of your drive pipe before attempting to start the pump. I thought I had done that. As it turned out, there was quite a lot still in the pipe and it was burping out a little at a time. Hold that valve wide open until it clears itself out. Wait for the reservoir to fill back up and then start the pump. Check in with us for periodic updates and to answer questions or fulfill any of your other alternative energy needs from solar, wind, inverters, electric pumps, and batteries. They all have their place. A common system is to use the ram to get water to a 500 or 1000 gallon tank and then use a 12 or 24 volt pump to pressurize delivery into your house or cabin.
Thanks for watching. If you like the video, give it a thumbs up and share it with your friends. For more tutorial and tips, subscribe the channel.